In this video, I wanted to give a little bit of an update on my CNC project. Probably about a year ago, I did a video similar to what this will be, talking about where I was and the problems that I saw. So it's not done yet, but some progress has been made and I've learned some stuff and I figured I should share that. So basically, this here is the idea. This way, up and down, and this way as well, using ball screws here. Ball screw this way, driven by, at first I thought NEMA 17 motors, but I'm actually going to end up with some NEMA 23s, at least for the X and Y. For the Z, I'm still on the NEMA 17s. So, things that I've learned. So first off, I'm using some aluminum extrusion that I bought from Motedis. It's a company here in Germany. I live in Germany at the moment, or for the last couple years. There are a couple of different slot sizes. There is the small one, which I bought, and then there's the bigger ones. This here is 20 by 20 millimeter. This is 30 by 30. This slot is a little bigger. The 20 by 20 also comes in the nut 5. This is the nut 4, I believe. And there's also, for the 30 by 30, there's the nut 8. And what that refers to is what size of nut can you use. So I've got these guys here off of AliExpress, and if you try to get them to go into here, it really doesn't fit. So big pain. But if instead you put it into the proper size extrusion, then it works just great. So there's a couple of kinds that you can get on AliExpress. There's these, as well as these other ones. The other ones have this little ball bearing, ball nut thing. Anyway, so that's learning number one. Make sure that you get extrusions where your slide nuts or your toggles or whatever actually fit. So, second mistake, perhaps this should be a fail video. When you have them cut it to the right length. I had them cut it based on this dimension and not on this dimension. My rails are about 20 centimeters longer. Duh. So measure twice, 3 or 4 times and cut, and just have them cut once. Thankfully though, from Motedis, these are not really that expensive. I bought these two plus a spool of PLA 3D filament for 25 shipped. I think they're about 6 or 7 euros per meter. And they have a $5 or €5 shipping flat rate as long as your purchase is less than 20 euros, something like that. I haven't tried the filament yet. I can't comment on that, but it's pretty cheap compared to, at least to Amazon and what I've also heard in other places. So that's learning. There's some more learnings there. Now, next thing is that these pillow blocks, I think they're called, for holding the ball rails are very nice. But they do have some amount of distance that they have to be above. In order for me to get this thing here to fit under here, there's a minimum height requirement. And that minimum height requirement is not satisfied by the 20 by 20 rail plus the, I think this is 12 millimeter linear rail. So for that, what I did is I put some shims here. I have some acrylic here. Use that to kind of lift everything up. I'm going to replace that when I get the right size with these, and then everything should be just dandy. One thing that's important to me based on the other CNC machine that I made when I was still living in Portland is that having the machine way up high and then having the router have to reach way down, there's a lot of space there for flex. So for me, it's important to me to have everything kind of as low profile as I can get it while still being able to have my material underneath. My intention is to really only cut sheet goods that are maybe an inch, so 3 centimeters, 2.54 centimeters. And so that would fit under here because, again, I mentioned in my other video one thing that I did learn in my Portland CNC machine is that the machine needs to hold the router in place. It needs to kind of manhandle it and say, okay, you're right here, and if the bit catches on something, it needs to stay put. It needs to stay where it is. Otherwise, you get a bunch of chatter, and things really just don't work out as nicely and smoothly. So rigidity, I've learned, is really important with the CNC machines. There's a lot of machines out there that use the extrusions that it seems like there would be a lot of space for flexing. But anyway, my experience is that rigidity does matter. So next thing that I learned is that originally I tried to cheap out by using these NEMA 17 motors. These are used commonly in 3D printers. And I tried using it to drive this main axis here, which you can kind of see. This is the 23 here. With the 17, it was missing steps a lot. I found that, especially since I'm using wood, I think if you use maybe aluminum plate, it'd be much easier to have things in alignment. These rails, they bind, and so you end up with some friction there. Also, one thing that I'm doing is that this rail here is actually 2 pieces of linear rail, which they come together right here. And that works pretty well. I'm pleased with it, except for as you go through it, it adds a little bit more friction. And so I found that I was missing more steps with the NEMA 17 as I was going over that. With the 23, all that was solved. And the 23, I'm not using a fancy controller. I am using here, which this is only kind of my remote control. I have one of these driver boards, again from AliExpress. I love the Chinese. And it's got the DRV something drivers on it. And I'm really only using, it doesn't draw a lot of current either. I'm just using it. It's a 12 volt power supply that I got from my router, which I think only delivers an amp or 2. Still having said that, I am going to try out these other drivers that I also got off of AliExpress. These are supposed to be able to go up to 4 amps, 3 amps, 4 amps peak, and up to 42 volts. I have a 36 volt power supply. I think my experience is that the voltage matters for how quickly you can get the thing to turn, just to be able to overcome the induction of the motors, is my understanding. And then the current is for the actual torque at a given speed. So I'll try these as well, but still the cheap, $3 DRV 82 something. They work pretty well as well. Of course, the whole thing doesn't work yet, but just for my tests of having it move around, it's pretty good. Also, in case you're wondering, I'm using my son's old Playmobil remote control thing where one of the wheels broke. And so I'm using that to control this STM32 blue pill board, which then delivers some steps to the driver board. But that part you don't really care about, so I'll put that to the side. So, My next, so in the previous video, I had just a single of these guide bearings in the middle, but I was getting a lot of flex that way. Once I've got 4, it's solid. I'm very pleased with it. So moving along, so I have this lead screw here, which in theory can give me that much, which this I think is 33 centimeters, about a little over a foot of a travel in this way. I think this way I'd end up with 600 millimeters, I think. You would think that your first inclination is to do bigger is better, but I found that with my other machine that most of the things that I was doing is pretty small. You know, just like with the 3D printer, you're thinking, well, you know, a small like 6-inch radius is really not enough. You'd be surprised how many things you can print. All right, so the next step is, so I have these guys here. This guy here is not one thing. People make a big deal about like, don't ever let these things come off. It actually isn't a big deal if they do come off. Here you just have these little ball bearings. And as long as you're careful, and even if they do pop out, there's these little metal rails that you just pop the ball bearing back in there and stick it back on there. It's not really a big deal, unless you're living someplace where there's carpet. That probably would make it harder. Anyway, so once that's fastened down, which actually even this will change, then this here come on there. One thing that I really want to make happen on this project is to use sort of more the MechMate style car, or truck or train. I forget what word they use for it. Instead of the thing where it goes up like this. My experience with my Portland CNC machine is that things really want to flex around, whereas here, like this guy here, this board here is solid. So now, again, trying to keep a low profile, here going left to right, where does the lead screw go? So next fail is my intention, my thought, had been to simply run this thing here through this hole and this hole. But the problem with that is that by the time you've done all of that, and then you put this guy over here and this guy over here, you don't really have any travel. So before I was saying that, well, bigger is not always better, to a point. So my next plan is to actually have what I want to do is put a slot in here. Actually be 2 pieces of wood here, and then 2 cross pieces here, glued and screwed together. I don't have to worry about racking this way since I do have 4 contact points. My main worry is whether it would flex this way. But again, since I'm not spanning a big distance, I'm hopeful that that will still be rigid. So what that enabled me to do is have in here, have the ball screw thing here down below there. And thereby enabling me to basically have, if we look at it from the end, a little rambly here, but basically it'll be kind of at this profile down here, right? So here. And so then that means these 2 lead screws here will be kind of close together like this instead of being like way apart, which that part doesn't matter, but still I can keep it low profile. Also driven with a NEMA 23, second NEMA 23, and I'll still stay with the 17 from above, as I mentioned. Also, one thing that I tried at first, when I realized I needed to use the Nemo 23, I tried using one of these fixed couplers that has no flex. The problem though, and can you see it in the camera? As this thing here turns, the motor here is actually kind of moving around. So instead, I plan on using these. I've read some complaints about like that they actually kind of turn or flex or twist a little too much. Hopefully that won't be an issue for me. But also, you know, the Chinese are my friends. What else might I add? I guess that's it. Anyway, hopefully the next update will not be a year from now, but rather maybe be less than a year from now. And at that point, I think I'm fairly hopeful that I'll have something actually to demonstrate. I'll have new ones of these. I'll have this guy here. I want to say, I'm not sure that I showed here. It uses the 8mm linear rails here. That I'm pretty pleased with. This guy here still flexes a bit. I think I'm gonna have to put a cross member here. I'm using a RC motor based spindle here, which that's in my other video. Anyway, I guess I'll stop rambling now and hope you found this useful. Comments are always welcome, and hopefully I'll see you soon.